Today is a super important milestone. We are starting object-oriented programming, or OOP for short. If variables and methods are like building blocks, OOP is the blueprint behind the Ant-Man suit. It tells us how things should be made and how they should behave. So what's a class? A class is like a blueprint. Imagine a car blueprint. It defines what every car should have, like brand, model, price. But the blueprint itself is not a car. And what's an object? An object is the actual car built from the blueprint. Example, class car, string brand, string model, in price, void drive, system.out.println, brand model is driving, public class car demo, public static void main string args, car1 equal to new car1 dot brand equal to Tesla, dot model equal to model 3, dot price equal to 40 grand, car2 equal to new car2 dot brand equal to Toyota, dot model equal to Corolla, dot price equal to 25 grand, system.out.println, car1 dot brand dot model dot price, system.out.println, car2 dot brand model price. And we'll call the methods call1 dot drive, call2 dot drive. So the output will be car1 is Tesla Model 3 40 grand, car2 is Toyota Corolla 25 grand. Tesla Model 3 is driving, Toyota Corolla is driving. How to think OOP? Class is the blueprint. Object is the real world thing created from the blueprint. And the variables inside class are properties like brand, model, price. And the methods inside the class are behaviors like drive, brake, honk. So this is the foundation and everything in OOP builds on this. We are stepping into one of the coolest OOP concepts, inheritance. So what is inheritance? Inheritance is like passing down the traits in a family. If your dad can play guitar, maybe you also can, or at least you'll inherit the skill. In Java, a child class can inherit properties and methods from a parent class. We use the keyword extends to do this. Let's say we have a vehicle class. Every vehicle has speed and fuel. Car and bike are special types of vehicles. They both share common things, speed and fuel, but also they have their own special features. Let's write a Java code so we can understand it more clearly. Class vehicle, int speed, int fuel, void start system.out.println, vehicle is starting. Void stop system.out.println, vehicle stopped. Child class car extends to vehicle, int doors equal to 4. Void show car info system.out.println, car with doors. Child class bike extends to vehicle, boolean has kickstart equal to true. Void show bike info system.out.println, bike with kickstart plus kickstart. Public class inheritance demo, public static void main string args, car equal to new car dot speed equal to 120, dot fuel equal to 40, dot start, dot show car info, dot stop. System.out.println, bike equal to new bike dot speed equal to 80, dot fuel equal to 10, dot start, dot show bike info, dot stop. And the output will be vehicle is starting, car with 4 doors, vehicle stopped. Vehicle is starting, bike with kickstart, true, vehicle stopped. So basically inheritance is the reusability. Instead of writing speed and fuel for both car and bike, we wrote it once in vehicle and reused it. The keyword extends make our class inherit from another class. Child classes can add their own features on top of the parent features. Think of it like Iron Man suits. The base Iron Man suit has the flight and AI in it. But then Iron Man makes special suits like Hulkbuster, Mark 85. They all inherit the same base properties but with extra power. That's inheritance in action. And overriding. Now let's unlock a superpower of Java, polymorphism. So what is polymorphism? The word polymorphism literally means poly is many, morph is forms. It means the same thing can take many forms. For example, a payment can be done by Apple Pay, Google Pay, UPI, card or cash. But no matter how you pay, the action is always the same, making the payment. There are two types of polymorphism, static polymorphism and dynamic polymorphism. Static polymorphism is the compile time polymorphism. It uses method overloading. Same method name but different parameter list. Example, making a payment by amount only or amount and discount. Dynamic polymorphism is the runtime polymorphism. It uses method overriding. Which version of the method runs depends on the object you create at the runtime. Example, payment through UPI, card, cash, Google Pay, Apple Pay, all these things. The make payment method behaves differently at the runtime. So let's write the code for it. Let's have a parent class. Class payment, void make payment double amount, system.out.println paying dollar plus amount. Static polymorphism, void make payment double amount string coupon, system.out.println paying dollar plus amount plus using coupon plus coupon. Let's have a child class for card. Class card payment extends payment. Override void make payment double amount system.out.println paid dollar plus amount plus using card. Child class for cash. Class cash payment extends payment. Override void make payment double amount system.out.println paid dollar plus amount in cash. Public class polymorphism demo. Public static void main string args. Static polymorphism. Payment base equal to new payment. Base dot make payment 50. Base dot make payment 100. Discount 10. Dynamic polymorphism. Payment P1 equal to new card payment. Payment P2 equal to new cash payment. P1 dot make payment 200. P2 dot make payment 300. And the output will be paying $50, paying $100 using coupon discount 10, paid $200 using card, paid $300 in cash. Static polymorphism is the method overloading, which is decided at the compile time. Dynamic polymorphism is the method overriding, which is decided at the runtime based on the object. Today we are talking about encapsulation, which is basically the idea of wrapping your code like a protective shield. So what is encapsulation? Think about your phone's lock screen password. You type the password to unlock, but do you know how the phone is actually verifying it inside? No, that's hidden from you. You only interact with the public interface, the keypad. The internal working is entirely private. That's encapsulation in Java. You hide the internal details and only expose what's necessary. Let's write a code for user password management to understand encapsulation clearly. Class user, private string password, public void set password, string pwd, if pwd.length greater than or equal to 6, this dot password equal to pwd, system.out.println password set successfully, else system.out.println password must be at least 6 characters long. Public boolean check password string input, return this dot password dot equals input. Public class encapsulation demo, public static void main string args, user1 equal to new user1 dot set password 123, user1 dot set password secure 123, system.out.println user1 dot check password wrong pass, system.out.println user1 dot check password secure 123, and the output will be password must be at least 6 characters long, password set successfully, false, true. Here, private variables keep the data safe from outside interference. Public methods are like the door handles to interact safely with the private data. Just like you don't give someone your raw bank account database, you give them an ATM card and a PIN system to interact securely. Think of Iron Man suit. You don't get direct access to writing or arc reactor. You only press buttons on the inside interface and suit does the complex stuff. That's encapsulation. So in short, encapsulation is data hiding plus controlled access. It keeps our program safe, modular, and easy to maintain. Today we are diving into abstraction, one of the most important OOP concepts. So what is abstraction? Abstraction is all about hiding the unnecessary details and only showing what the user really needs. Think about an ATM machine. You insert your card, you press buttons to withdraw money, check balance, deposits, etc. Do you know how the ATM is connecting to bank's database? How the money is being verified, or how it prints the receipts? No. All of that is hidden. You just see a simple interface. That's exactly what abstraction is in Java. Let's write a code for ATM machine interface. Abstract class ATM, public abstract void withdraw double amount, public abstract void check balance, public void insert card, system.out.println card inserted, please enter PIN. Class bank ATM extends ATM, private double balance equal to 5000, it override public void withdraw double amount, if amount less than or equal to balance minus equal to amount, system.out.println please collect your cash dollar plus amount, else system.out.println insufficient funds, it override public void check balance, system.out.println your balance is dollar plus balance. Public class abstraction demo, public static void main string args, ATM equal to new ATM.insert card, ATM.checkbalance, ATM.withdraw 2000, ATM.balance. And the output will be card inserted, please enter PIN. Your balance is $5,000. Please collect your cash $2,000. Your balance is $3,000. In here, abstract classes act like blueprints. They say what should be done, but not how. Different banks can have their own ATM implementation. The user doesn't care how the backend works. Abstraction makes code flexible, reusable, and easy to update. Think of Jarvis in Iron Man suit. Tony just says, Jarvis give me flight mode. He doesn't need to know every line of code Jarvis is running in the background. That's abstraction. So in short, abstraction is showing only what's needed and hiding the rest.